All right, guys, so here's how to do your atom bonding project. Okay, so first thing you're going to do, you're going to pick an atom with a positive charge on the left-hand side of the periodic table of ions, okay, which is on your slide 2 reference slides, right? So boom, I'm going to go ahead and pick potassium, which has an atomic number of 19. I wrote that on my little post-it note here. I put that it's K plus, so I just put potassium at the top, K plus, and then 19, the atomic number. Okay, that's my first atom. Now I'm going to pick an atom that has an equal and opposite charge on the right-hand side. So potassium has a plus charge of 1. So I'm going to find something that has a minus charge of 1. So I'm going to pick bromide. Now you guys can pick whatever 2 atoms that match, that have equal and opposite charges. Okay, bromide means it was bromium. So I'm going to put bromium, Br. If you don't know which one it is, it's fine. Just put the ion. This is called the ion name. So I put bromide, Br minus, which means -1, and the atomic number of 35. All right, so I wrote that in my post-it note. Then I'm going to go to the electron configuration chart. I'm going to press the present or slideshow button, which shows up as a triangle in the top right-hand corner for iPads and tablets. All right, present on this device. All right, so now I'm going to fill up the electron configuration chart for potassium. So since the atomic number of potassium is 19, that means it has 19 protons in the middle, right? That's the atomic number. If it has 19 protons in the middle, that means it has 19 electrons orbiting around it. So let's fill up 19. Boom. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so next thing I'm going to do, I'm going to screenshot it. All right, I'm going to give myself a little bit of room here. Okay, I'm going to screenshot it, and I'm going to crop that because I don't need to see all the words and stuff. I just want that. Okay, and then I'm going to go ahead and write. So this one was potassium, which is K. I'm going to write it right here at the bottom. So that's potassium. Trying to get out the way of the electrons. Okay, which has an atomic number of 19. And I'm going to put the charge that I wrote down, which is +1. Now I'm going to do-si-do and from the electrons. So this is how you're going to do the do-si-do part. Look at its most outer shell. Right? I can see there's no electrons in the F shell. Right? This is the F shell at the fuchsia one. There's no electrons there. There's only electrons all the way up to the D shell. So I'm checking the D shell, and I'm going to do-si-do my electrons on the D shell to make sure they have a partner. Okay? So this one is partnered with this one. This one is partnered with this one. This one is partnered with this one, but this one, oh no. Oh, hold on. This one, if you notice, is missing a partner. Aha! It's missing a partner. So because it's missing a partner, it's going to, well, according to the charge, it says it's a +1. If it's a +1, that means it's gonna lose an electron. That means it's gonna want to lose this one. I get the story now. This is the one it's gonna want to lose, right? So I'm gonna put that will want to lose this one. Once it loses this guy right here, once it loses it, boop, then it's going to have less electrons. It's going to have only 18 electrons compared to 19 protons in the middle. Remember, it was 19 in the middle. Okay, so that was 19 protons. and it'll only have, after it loses that one, it's going to only have 18 electrons. Because it's only going to have 18 electrons, that's why it has a +1 charge, because it has more protons to electrons. I get it. That's the idea. This is what you want to get. So definitely write over your electron configuration chart, because it's going to help you out. Okay, so then you're going to do the same thing for your second atom that you wrote down on your Post-it note. Mine was bromium, which has an atomic number of 35. So that means I got up to 19 for potassium. So now I'm going to fill it up to 35. Okay, so I go 20. Where did the 20 go? Where's my 20? There we go. Here's my 20 right there. All right, here's my 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Boom. All right, so I got this one. All right, I'm going to screenshot this. All right, and I'm going to label this one. So this one was bromium. All right, which is bromium. And if you don't know, because I kind of like have been working with the periodic table of elements for a while, so I know that bromide means it's a bromium atom. If you don't, like, if you wrote down bromide, like it has an "ide" at the end, the "ide" just means it's an ion. It has a charge, specifically a negative charge. So that's fine. You can write bromide if, you know what I mean? Cause, that's fine, because you guys will get the hang of it after a while. You start remembering the names of the actual atoms. So boom, I'm going to put its atomic number, which was 35. I'm going to put its charge down, which was -1. -1. Okay, so now I'm going to do the do-si-do and see. The mistake I made in class is I was like pairing up spots that didn't exist. Only pair up the electrons. That's why I made this reversion right here. So I'm going to check the outermost shell. So here the outermost shell is the fuchsia colored one, which is the F shell. So I'm checking the outermost shell, and I'm do-si-doing my electron partners. So this one has a partner over here. This one has a partner over here. This one, is missing a partner over here. Right? So for bromium, it says right here that bromium is going to want to that's so interesting. So interesting. Bromium is going to want to lose this electron. No, I'm tripping. Bromium is going to want to gain an electron, right? So boom, Br, I'm going to put that Br will want to gain one. Okay, I'm having a hard time fitting this in, so I'm going to put it here. Electron. Bromium will want to gain one electron. So once it gains the electron, that's going to make the electrons then it's going to have one more. So it's going to have 36 electrons. Oops. Electron. Make that nice. And remember, its atomic number was 35, which means that it had 35 protons. So if it had 35 protons and then it's going to want to gain an electron, that's going to give it a negative electrical charge. It'll have 36 electrons, 35 protons, which gives an electrical charge of -1. Right now, this is interesting, right? Because we're gonna talk about that in a second. But okay, so once you have this, so then boom, you have the name of the element on the bottom left hand corner, the atomic number. All right, you did your do-si-do of the electrons on the outermost shell, and you look back on your charge that you wrote down on the bottom right hand corner, and you kind of understanding the psychology of this atom. Like, oh, so bromium is going to want to gain an electron according to its charge. Because it wants to gain an electron, that's going to give it one more electron than the balance. It's going to be 36 electrons to 35 protons, which gives it a negative charge. So freaking, I love it. It's so cool, so okay, so now what you're gonna do, so go back. So now that you got this, you're gonna go to your presentation. All right, let's go to your presentation. Here's my presentation, and I'm gonna delete this because I kind of want to make sure that I have the correct ones. Okay, so here's I'm going to add my atom. So I press the plus sign if you're on a tablet. Let me show you how I did that. So there's a plus sign on the top right-hand corner, and that allows you to add images. Then I go down to image from photos, and then I click those images that I just screenshot and wrote over. So now I have my really cool electron configuration chart. And now, actually, it already did it for me, but I was going to say whatever the bigger atom is, make that bigger. Because in real life, it actually is going to be bigger. So in this case, bromium is the bigger one. And potassium is the smaller one because it has 19 protons, and bromium has 35. So now I kind of understand the psychology of it, because I'm like, okay, bromium is going to want to gain an electron and potassium is going to want to lose an electron, which is why they bond. Then I'm going to Google search. Hold on. I'm going to rearrange this though, because the +1 should be first and the -1 should be second. There we go. All right, so now I see I have potassium bromide. Potassium bromide. Yeah, I'll just go ahead and I should have just wrote bromide. Okay, potassium bromide. Now I'm going to research that. I'm going to Google it. It's like, whoa, it makes sense. Potassium is going to want to lose an electron. Bromium is going to want to gain an electron, which makes sense why it's a perfect match. Now I'm going to search potassium bromide and see if it's a thing. And sure enough, it is a thing. See, I already searched it right here, so let's just pretend like I just added it. Okay, here we go. It's a thing. I screenshot it, right? So I can show you that it's a real thing. All right, but I really want to know what it's used for, because I don't just want to know what's the thing. I want to know, what is it? It's a halide anticonvulsant used in veterinary medicine for the treatment of epilepsy. Super important, right? So boom, this is, right? So then boom, down over here, that's all I'm going to do. I'm going to put those screenshots in. And how do you put the screenshot in? You press the plus sign, image, same thing, and pick your photos. Right over there, press add. Right, so that's how you add your image. So this is it. This is all I want to see for your homework. So your first slide is going to have your title page. I put a matchmaking chemistry, how two atoms bond. My second one is going to have my notes on the electron configuration chart, so I can understand, okay, potassium wants to lose this electron, bromium wants to gain this electron, and that's how you have potassium bromide. And that's it, my friends. That's your project. So I'm really excited to see how you worked out your electron configuration chart so that it makes sense. Okay, and we'll go over this next class. Yay! And I'm here if you have any questions at all. I love this, you guys. Like getting down to like how atoms work is so fascinating. I think it's also very fascinating that potassium wants to lose this electron, right? Whereas bromium doesn't want to lose this electron. It just wants to gain one. That is so fascinating to me. Like, why? You know what I mean? Like, why does this one want to lose this electron and why does this one want to gain it when they're kind of in a similar situation, right? And I think that's a question for quantum, quantum mechanics. Why is it that when potassium and bromium are kind of in the same situation, why does potassium want to lose one, and why does potassium want to lose an electron and bromium want to gain an electron, right? Because that's what the charges will tell you. I think that's a very fascinating question. But for whatever reason, one wants to lose one wants to gain one, and they turn out to be a matchmaking chemistry, right? And that, my friends, is the foundation of chemistry. Whew. Don't you love it? I love it. It's just like, I like to see it in this electron configuration chart too, because it's more realistic, I feel like, than filling out like, a black and white sheet of paper. Because then we're looking at, these teeny little energy systems, So, yeah, I'm here if you have any questions. I'm just so excited. Look at y'all. Look at us over here at Foundations of Chemistry.